Okay, let's turn next to further diagnostics, and they refer to what is known as the R squared. And the R squared is actually quite important, but it's not everything, but you need to know it. So what is the R squared? So the R squared informs about the percentage of the variation of the dependent variable that is explained by the variation of the independent variable. And in ordinary least squares, what we have been doing in this lecture, the R squared is always between 0, meaning that the explanatory variable explains nothing, and 1, which is that the explanatory variable explains everything. So let's say if we have a model, and just to illustrate it, where we have, let's say, two extreme situations, maybe. So let's say we have our observations, and here we have something that looks like this. So that will suggest a very strong correlation. So those dots really explain, and of course there might be some dots here as well. So that is a very high R squared. But if we have something maybe like this, well, that doesn't explain much. That has a low R squared. So that's the idea of an R squared. And it is again a statistic that whenever we deal with OLS is between 0 and 1. And it has a formula, which is that the R squared is equal to the so-called explained sum of squares over the total sum of squares in a regression. And so here are the formulas. And first of all, the total sum of squares are the explained sum of squares plus the residual sum of squares. So there are like three things you need to know in order to understand the R squared, and that's the total sum of squares, TSS, the explained sum of squares, ESS, and the residual sum of squares. So the explained sum of squares explains essentially the squared variation of the predicted value away from the mean, or it explains the variation away from the average of the dependent variable that is explained by the trend line. And the residual sum of squares are simply the actual observations away from the trend line. That's the error term. And again, everything is squared. And the total sum of squares is simply the explained sum of squares plus the residual sum of squares. Let me explain that next in a graph, and you already see it here, but I'll just delete that again, and let's just derive it manually. Okay, and we can see here, but let's, okay. So again, what we need in order to derive the explained sum of squares and the residual sum of squares are our actual observations, the xi's and the yi's, and we have here already the mean of the x's, which is 3. So now when it comes to the explained sum of squares, we look at the variation for the first, we look at the first observation. Let's say the observation 0, 3 is our first observation. So now you can see that the trend line, so we look basically at the trend line, not the dot, the trend line exactly overlaps with the dot. But what matters is that the trend line predicts a 1, 2, 3 unit away from the average of y. The average of y is 6. It's the dotted horizontal line. So the trend line at the value of 0 would predict a 1, 2, 3 deviation from the mean, and we square that. And that makes it, the explained sum of squared is 9. So that's a 9. Okay, so now let's take a look at the next observation. So we have here, let's say we look at number 2. What matters is actually not to look at the 2, but the corresponding y hat. So the corresponding y hat predicts a 1 unit deviation below the mean of y. So the explained sum of squared is 1 squared, which is 1. Then we move to the third observation. The third observation will predict again, actually this dot here between between the dashed trend line, and it's again a 1 unit deviation of what would be predicted given the observation 2 and 6. So the observation, the third point is 2 and 6, but the trend line is at 2 and 5, so it predicts a 1 unit deviation, in this case below the trend line, a bit below the mean of y of 6, so that's another 1. It's because we square it. So then let's take a look at the fourth dot. The fourth dot is on the x4 and on the y-axis 5, but the trend line predicts a positive 1 unit deviation above the mean of y. So the trend line is actually at 4 and 7, and that is a 1 unit above the mean of y. So again, squared, 1 squared is 1. Okay, now let's move to the fifth dot. So the fifth dot is 4 on the x-axis and 9 on the y-axis, but again, what matters is what does the trend line predict, and the trend line predicts a 1 unit variation above, or a 1 unit deviation above the trend line, namely 4 and 7, whereas actually it's not, it's a 1 unit deviation from the mean of y. So again, the explained sum of squares, where's the trend line relative to the mean of y. So that's another 1 unit deviation, so 1 squared. And then the last observation has the x-coordinate 6 and the y-coordinate y. And the trend line also predicts 6 and 9. So the trend line predicts a 3 unit deviation from the mean of y, which is again another 9, 3 squared. So now we have 9, 10, 11, 12, 13, 22. So the explained sum of squared are 22. Now let's go to the residual sum of squared. That's a little bit easier. The residual sum of squares simply looks at the deviation of the actual observation away from the trend line. So again, the first dot with the coordinates 0 and 3 has 0 deviation. The trend line exactly predicts that dot, so the residual sum of squared is 0. Then moving to the second dot with the coordinates 2 and 4, well, there is a 1 unit deviation from the trend line, so we square that. 1 squared is 1. Then we move to the third dot. And again, here the third dot has the coordinates 2 and 6. And there's again a positive 1 unit deviation from the trend line, so 1 squared is again 1. Then the fourth has a The fourth dot with the coordinate 4 and 5 has a 2-unit deviation from the trend line. It's because the trend line at the fourth dot would suggest a 4 and a 7, so that's a 2-unit deviation, so 4 squared, 2 squared, that's 4. Then the observation at 4 and 9, the fifth observation. So the trend line would predict 4 and 7, but the actual observation is 4 and 9. So that is a 2-unit deviation, and that squared is again 4. And our final observation at 6 and 9, that exactly overlaps again with the trend line, which also at 6 predicts a y value of 9, so that's another 0. So the total residual sum of squares is 1, 2, 6, 10. But for the r squared, we need a total sum of squared. So in order to get the total sum of squared, we simply sum up the explained sum and the residual sum of squared. And that is 9, 2, 2, 5, 5, 9. So the total is 9, 11, 13, 18, 23, 32. So our r squared is 22 over 32, and if I quickly use my calculator, so 22 over 32, that is 0.6875. So 0.6875. So that is the r squared, and if we go to our Excel output, we see that we have here in the summary output already on the top the r squared, and here it is rounded to 3 digits, so we have 6875 rounded to 3 digits, it is 0.688. And this is how we explain the r squared. But we always got to be careful with the r squared, because while it is an important indicator, it is clearly not everything, could be misleading, and that is being addressed by the ANOVA table. But what's the point of an ANOVA table? I will do that in the next video. So I hope to see you in the next video.